All right, so we have talked about, and we talked about this day one. We talked about, this is statistics. Statistics is a description of a sample. And the reason we use samples is because it's very difficult to collect information on an entire population, especially when that population becomes large. So we're going to revisit some of that vocabulary today. So a population is an entire group of people or objects. And you'll notice I hole punched your notes wrong. So you're starting on the back. All right? Now, we talked about the type of method of collecting information from an entire population as a census. We perform a census in the U.S. every 10 years, but it's very costly, it's very timely, and it's usually not accurate. Why is it costly?
Yeah.
Well, first of all, they print all the surveys, they mail them to you, then some people fill them out and return them, others don't. When you do not, you get a visit from a person.
So you got to pay for it.
Yep. And then someone has to collect all the data and analyze all the data. So they're extremely costly. All right. If an approach, because it's often guys, you can either hush or go sit in an empty room. So because it's unreasonable and generally impossible to collect data on every member of a large population, if appropriate sampling techniques are used, a sample can be used to make predictions about a population. So the important things in here, it says, if appropriate sampling techniques. So we need a representative sample. It needs to be random. So if appropriate sampling techniques are used, that sample can be used to make predictions about the population, such as estimating an average or proportion of the population. This process is known as inference because we're inferring from our small sample onto the entire population. Okay? So if I surveyed 10 students from the junior class about what kind of music they want at prom, and 8 out of 10 agreed on this one type of music, if I had a representative sample that was selected accurately, I can infer that the entire population of juniors would enjoy this kind of music, or 80% of them. Okay? Now, when we're studying samples, the numbers that we get from those samples are called statistics. So a statistic is a number that describes a sample, versus a parameter is a number that describes a population. So statistic describes the sample. Statistic comes from a sample. S. Parameter describes the population. PP. Okay. If a random selection process that is used to produce a representative sample, so random selection, representative sample, sample statistics may be used to estimate population parameters. And that's what we just did when I was talking about the prom music. We took the sample statistics to estimate population parameters. Whoops. All right. Number 1. You're interested in the proportion of advanced algebra students. This year we call advanced algebra Algebra 2. Algebra 2 students that will end up with an A this semester. So, our population is all Algebra 2 students. And we have different ways we could sample. One way to do a sample would be to take a group of you. Miss Willoughby's third period. That's called a cluster sample because I chose one group.
It's a bad representation.
It might not be because there's a little bit of everything in here. Sometimes clusters are okay, but they're not ideal. We would want to go with a, huh?
Did you hear?
I did. All right, individual could be you because you're an Algebra 2 student. So the individual would be one Algebra 2 student. All right, and number 2, I forgot to erase my answers, so we'll just talk about my answers. So number 2, the mean income of all subscribers to a particular magazine is $26,000. We draw a random sample of 100 subscribers and find their mean income is $27,300. So what is the population? Well, the population in this particular instance would refer to all magazine subscribers. And the sample would only include those 100 randomly selected subscribers. So when we look at our data here, we have 2 pieces of data. This 26,000 was the information we got from all. So that would be considered a parameter. It's a parameter because it's describing the entire population. So the mean income of the population is 26,000. Now the other piece of data we have is 27,300. And that data was collected from a sample. Therefore, we would refer to it as a statistic.
Wow.
So our statistic would be the mean income of the sample, which is 27,300. Okay, so parameter versus statistic makes sense? All right. Now, number 3, it says the average GPA for all female volleyball players at a particular college is 2.8. Their mean height is 182 centimeters. Identify the parameter or statistic if there is any. All right. Now, the way this problem is currently worded, because it is all female volleyball players, these would be considered parameters. So they would both be parameters because it's information describing the entire population. But if we tweak this problem, even the slightest, if we said instead of a particular college, said this is all at a particular college in the NCAA, if we expand it to include all colleges instead of this particular college, then we now have a sample. But the way it's worded currently, this is the entire population. So this information on GPA and height are parameters.
How
Okay?
many inches is that?
There are 2.54 centimeters in an inch.
0.45. So about
So if you took 182 and divided by 2.54,
610.
no, that's not. That's a little. How many inches? 75?
71.
71?
Yeah, 6'8".
No.
No, that's way shorter.
Five-
Because
five-
no, 5'7" is
five-
69 inches.
72 inches
That's 5.
is 6 feet.
How about
So, and it's 70 how many?
Yeah.
71?
thought it was 71.
Hold on.
What is 182 divided by 2.54? 2.54. 71 inches. So that's 5'11". Okay, so it's about 5'11". That makes sense. When I was a freshman at Georgia Tech and I was moving into my dorm, I got the newest dorm on campus at the time, which was pretty cool. And I got on the elevator, and I was the shortest female on the elevator. And I am 5'9", which I'm not used to being the shortest. But all the volleyball players and basketball players lived in my dorm. So I was the shortest most often. And then my senior year, I moved into the newest dorm. It was newer dorm. And then it was co-ed. And the female and male basketball players and baseball players and football players all lived in that dorm. So that was kind of cool, except for the boys would walk down the hall dribbling. I'm like, really? Really? It was carpeted, but you could, the walls were thin. You could still hear something going on. Alright. I know.
That's probably the
Yep.
part that does that too.
Okay, number 4. In a survey of 40 employees at a company, 18 said they were unhappy with their pay. That's fairly high. The company has 180 employees, so obviously this is not the entire population. That's a sample, so the 40 employees would be a sample. And if we assume that this was a random sample that is representative of the entire population, then we can take this information and use it to make predictions about the entire population. So it would be, if 18 out of 40 of the sample, how many out of 180?
81.
And you're right, we would cross multiply and solve. And we would get x equals 81. So there are 80, if we use this information to predict, we predict that 81 employees are unhappy with their pay. Now, what do we call it when we take sample statistics and apply them to population parameters? We call that, that's right, inference.
What? No, what? How did I know what this is? Oh,